Hey guys, how's it going? Today I'm going to be reacting to another video by the channel Real Life Lore that caught my attention almost immediately or very quickly after I posted the last video that I did on Real Life Lore. I think it's the last video that went up on my channel. This one's called 142 Nonillion Degrees. What would happen next? Now, I gotta be perfectly honest, I had no idea when I read that for the first time what kind of number nonillion was. I had to look it up. Apparently in the USA and Canada, it's one followed by 30 zeros. 30 zeros. Like a million is 6 zeros, a billion's 9 zeros, a trillion's 12, and so on and so forth. This is 30 zeros. And apparently in the UK, France, and Germany, it's one followed by 54 zeros, so I guess it's a completely different name or completely different number that has the same name or whatever. But in USA and Canada, it's 30 zeros. So obviously, like always, this should be really interesting. I don't know where they're gonna go with this. What would happen? I assume basically everything would break down at that temperature because that's just an unfathomable number. But we'll see what they got. This really caught my attention, and let's see what we got. This should be interesting.
This video is made possible by Brilliant. Start learning intuitively with Brilliant for 20% off by being one of the first 200 people to sign up by clicking the link in the description. So the title of this video is What Would Happen If the Temperature Somewhere Reached 142 Nonillion Degrees, which for reference has this many zeros. The answer is weird, but to prepare you for it, we need to start with some weird things that happen at much lower temperatures. We can begin our journey at negative 273.15 degrees Celsius, also known as absolute zero or the coldest possible temperature in the universe. In 2003, scientists at MIT came very close to achieving this temperature when they got just a billionth of a degree above the limit. That means that the coldest temperature ever observed anywhere in the universe was actually just right here on Earth in this laboratory, and just barely above that at negative 273 degrees is the lowest temperature ever survived by a living thing, the cute but almost indestructible tardigrade or water bear. Once we get a little warmer to negative 216 degrees, we arrive at the coldest planet in the solar system, Uranus. Warmer still at negative 184 degrees is the average surface temperature on the dark side of the moon, and just 1 degree higher is when oxygen starts to boil. Earth is comparatively much warmer than most other planets, because the coldest temperature ever measured here naturally was negative 89 degrees taken at the Vostok station in Antarctica. The lowest temperature ever recorded in the US was negative 62 degrees in Alaska, which is even colder than the average surface temperature of Mars is at negative 55 degrees. Finally, at 0 degrees, we reach the melting point of ice, and just slightly higher at 13.7 degrees is the lowest body temperature a living human has ever had. The average human body temperature is 37 degrees, and 46.5 degrees is the highest recorded body temperature that a person has survived. 57 degrees is the highest temperature recorded in the US taken in Death Valley, while 71 degrees is the highest surface temperature ever measured anywhere on our planet, taken inside of Iran. But there are places out there in the universe that are far hotter than anywhere on Earth. Despite how cold the moon is on the dark side, the average temperature where the sun does shine is a sweltering 101 degrees. Despite these two opposite climates, the tardigrade I mentioned earlier could survive either of them. The highest temperature that one has survived was an amazing 151 degrees, but the universe still gets way hotter. 462 degrees is the average surface temperature of the planet Venus, the hottest planet in our solar system. Raising the heat even more up to 1027 degrees and we get to the maximum temperature of a flame burning from wood. Lava freshly erupted from a volcano can hit 1200 degrees, but candles can burn even hotter up to 1400 degrees.
Really?
Eventually we hit the boiling points of silver, iron, and carbon, and at 5000 degrees we reach the temperature inside the initial blast of a conventional chemical bomb. The temperature you would encounter at the surface of the sun may seem very high at 5,500 degrees, but the temperature inside of the Earth's core is even hotter at 6,000 10,000 degrees. But hotter than either of those is the temperature inside the fireball of a nuclear explosion, which can be up to 10,000 degrees or even more. But outside of the sun's surface, the sun's upper atmosphere can reach an unbelievable 1 million degrees. Down at the sun's core, the temperature can reach an even more insane 15 million degrees. But that's nothing compared to the heat generated from the blast of a supernova. When a star enters into a supernova state, it heats the gas around it to a mind-boggling 55 million degrees. When smaller stars collapse into neutron stars, though, the newly formed neutron core has a temperature approaching 100 billion degrees, which is 6,666 times the temperature found inside of the sun's core. But the hottest temperature ever recorded anywhere in the universe was right back here on Earth, created by scientists at CERN in Switzerland. Using the Large Hadron Collider, they created extremely fast collisions of lead ions that briefly generated a temperature of 5.5 trillion degrees, which sounds like a lot, but it was limited to a very tiny area around where the ions collided. But the hottest temperature that might be possible in the universe is completely unbelievable. 142 nonillion degrees is the temperature at which our conventional understanding of physics begins to break down. In theory, there is no limit to how much energy we could put into heating something up, but there so far is no scientific theory for how matter might behave at this high of an energy level. We simply don't know what would really happen if we managed to heat something up this hot, but we can speculate a little. This temperature is known as the Planck temperature, because the radiation emitted from an object this hot would have a wavelength equal to the Planck length, a distance so unbelievably small that we don't know how or if we can measure distances that are smaller. Because you would be condensing so much energy into such a small point, going beyond the Planck temperature could be enough to turn the area or thing you were heating into a black hole. Creating a black hole with energy instead of mass like this is called a Kugelblitz, and it could pretty quickly become a bigger problem than whatever damage the heat would have caused to you. Our math so far can't describe what exactly would happen if we went beyond the Planck temperature. It may create a black hole that would instantly radiate away, or it could destroy the Earth, or it may do something else completely unexpected by anybody. The mathematical models that we've developed so far are incapable of explaining it, but if you'd like to take your shot at it and go down in history as a scientist celebrity, you'll need an understanding of things like calculus, quantum mechanics, and general relativity. The numbers and concepts that go into learning these things are hard and confusing for a lot of people, including myself, but taking the courses over at Brilliant has helped me enough to feel confident making videos like this one. Rather than telling you how to do calculus by making you memorize things, they start by teaching you.
Okay, that was a little mind-boggling. Obviously, I mean, wow. I knew about the Planck temperature and all that. It's where the wavelength is the Planck length, which is, according to the math, the shortest possible length possible in our universe. Anything beyond that, it's theoretical, but anything beyond that, the math just breaks down. It doesn't work anymore. So there could be things smaller than the Planck length, maybe not, but we just don't know. We likely will never know, or in the very distant future will we figure this stuff out. But that was just incredible. And like I said, I don't think really anything can. Everything, I feel like everything would break down at that temperature, not just the math, but like literally. I'm just at a loss for words, because it's just such an incredible, unfathomable like temperature that I'm sorry guys, I honestly don't know what to say. That's just it's really interesting, but yeah, I guess that's all I got for this one. This was just incredible. Like I said, I'm just mind blown. And like theoretically, there's obviously, like he said, there's no limit technically to supposedly to how much energy we could put into a system, how much thermal energy we could keep adding. but we just don't know. I think the math may break down if we get beyond the Planck temperature as well. So we just don't know, and obviously we're probably never going to know in practice or in the very distant future. But yeah, this was great and informative, and as always with this channel, Real Life Lore, it keeps you engaged, and it's really he tells it in explains things in a really interesting way. So if you want to see the original video, I'll link that in the comments below. And all right, make sure to like, comment, subscribe, and I guess I'll see you guys in the next one. All right, bye.